So hi there. So welcome back to the channel. My name is Abatan Sheriffdeen and welcome back to Excel Island. So what I basically do on this channel so far is that I've been live streaming my learning journey or learning SQL on the Datacamp platform for the past 54 days. So today is day 54 and the goal is to be consistent with the learning, showing up 30, 45 minutes, 1 hour every day for the next 100 days. So I've been able to do that for the last 54 days. Here it comes. Let me show you what that looks like. So I've been able to do that for the past 54 days, and I've completed almost like seven. I think I'm on the eighth course on the platform. So I'm on the data analyst in SQL career tracks. So I'm 64% through the course. Let me show you what it looks like. So after this, I'm planning to start the data analyst Power BI career track also. So this career tracks now contains 11 courses. You get it now. It's over 39 hours. You will definitely I'll spend more than that practicing and so on. So I'm able to complete 7 courses here. So I'm on the eighth course, which is exploratory data analysis in SQL. So I've been doing that for the past 54 days. It has been an amazing learning journey, trying to learn consistently and cover as much as possible to upskill myself as a data analyst. I'm currently a top rated plus freelance data analyst on the Upwork platform. So I've been freelancing for the last 2, 3, 4, getting close to 4, 5 years now. You get it now. So I've had major success on the platform. And that's because I have a coach who has actually put me through all that so far. So the name of the coach is Bengadidi, and he currently has a course going on. So the name of the course is the Freelance Client Magnet course. So, and what this course does is that it teaches you how to become a successful freelancer on major platforms like Upwork, Fiverr, LinkedIn, remote job website, or even using your social media accounts, your normal social media account, to optimize yourself and position your profile for what? For clients and gigs. Also, this course contains that. The course also teaches you how to price and charge premium for your expertise. So I'll leave a link to the course under the YouTube description of this video. You can check it out and purchase the course. You get it now. Also, when you purchase the course, you have access to an amazing community of freelancers who are ready to help you and help you become a successful freelancer also. I also leave a link to Bengali Twitter account. If you go to Twitter or X right now, and if you search for Bengali BE, there is him. So you see, check out his pin tweet. You see tons of testimonials that he has shared from amazing freelancers that he has coached who have become successful also. You get it down. So let's get back to the course. So I'm on exploratory data analysis. So every day I tend to learn, make sure I show up every day, 30, 45 minutes, 1 hour, and learn something. So my goal is to complete this course before I'm almost through with the course, with this career track. Then there are tons of there's the projects, then there's statement of accomplishment. There's also certification by Datacamp. So I plan to take this certification also so I can become satisfied using the Datacamp platform and use it to apply for jobs and gig also. Also after this, I plan to do a lot of projects on SQL at least before the end of the year, probably like 4 to 5 or more projects. Then I continue with the Power BI career track also. So without further ado, let's get back to it. So if I go back to the progress dashboard there, so if I continue from where I stopped in this exploratory data analysis, there's nothing to review today. So sometimes I've got to review a couple of weak areas from what? From past lessons or from past um, courses in the career track. But I think I'm good to go. I'll just continue from here and keep making progress. So let me just open the file from somewhere here. So I'm trying to open the slide. So when you check this course, which is the exploratory data analysis, so I'm seeing chapter 1, and there's chapter 2, chapter 3, and chapter 4. Then I move to the what? To the next course. Let's finish the chapter 1 today. So paralysis, that is from my yesterday live stream. So if you want to watch you want to follow me along to watch from the beginning of this, what is the database, you can check yesterday's live stream. So you'll find it there. Let me just continue from here. It says the coalesces function can be useful for specifying a default or backup value when column contains null values. So coalesces checks arguments in order and return the first non-null value if one exists. Coalesces 1 null 1 2. So this return 1. Coalesces null null null. Coalesces 2. I still need 2 here. It returns 0. Coalesces checks argument in order and return the first non-value. So the first non-value here is 1. There is no null value here. The first non-value here is 2. So in this Fortune 500 data, industry contains some missing values. Use coalesces to use the value of sector as the industry when industry is null. Then find the most common industry. Okay, it says in the Fortune 500, this is the Fortune 500 table. Industry. Let's go to the industry. Yeah, the industry column here says contains some missing values. It now says we should use the equalities function to use the value of sector. Okay, we go back to where is sector. Use the value of sector as the industry when industry is not in that particular role. Okay, it says use coalesces to select first non-values from industry, sector, or unknown as a fallback value. So select use coalesces. I'm going to use coalesces here. I'm going to call on the function. And it is. So let's say use coalesces to select first non-value from industry. From industry here. This select when it checks the row for industry, then we are going to use the sector part to replace the unknown as industry 2. Don't forget to count. Okay. Alias the result as coalesces or industry 2. That has been done for us. From Fortune 500, there's something missing here. I'm supposed to be counting something. There's something. Since you are using go by, I'm supposed to be counting something. So there's a go by clause here. So go by what? What are you counting by? It says count the number of rows with each industry to O. Find the most common value of the industry. Okay. Alias the result of the call to coalesces as industry 2. Count the number of rows with each industry 2. So I'm going to say count. Count. So with each industry 2. So I'm going to count this. So go by. Let's go by industry 2 also. You can go by that. So that is wrong. Can see other by. Give me the result to get just one value you want. If you find the most common value of industry 2, Limit results to get just the one value you want. Most common value of industry two. Limit. First thing we're going to limit to one. Okay, yeah, limit to one since the most common. Then the so go by what? What are you counting by? You are counting by I'm trying to figure out what you are counting by there. Count the number of rows with each industry two value. Count the number of rows. Come on, think. Alias the result of the call to queries as industry two. Then counts the number of rows with each industry two. Hmm. So I'm counting by industry. So that won't be fair, but let's use aliases also to count. Let's give it a shot and see. It's not going to make sense. Industry 2 doesn't exist. It says count number of rows. Oh, oh. Let's see. Aha, I got it. So my mistake was I'm now supposed to count star. If I count star, this I'm selecting coalesces the industry sector. Even if I don't count, okay. I'm now supposed to be counting each rows in the record. Oh, order by the correct column. That's correct now. Hmm. Let me see, find the most common value. Find the result of the call to coalesces as industry 2. Count number of rows with each industry 2 value. Number of rows with each industry 2 value. Find the most common value in the industry. But my other way, order the result to see the most common first. The most common first. Oh, trying to figure this out. Oh, I don't want to take the ints. I think I decided to take the ints there. I don't want to. Yes. So go back to this place. So this coalesce is going to select coalesce industry. We're going to return this industry in space that it is not seen. Let me look for one blank record here from the industry here. look at this null value here. So when this correlates, check this industry column and see this not value, we're going to return this instead. Then this unknown, that means if there is two null values in these two columns there, it's going to return unknown there. That is correct. So I'm trying to explain the function, how the function works. You have not name it as industry 2. So whenever it sees another industry, that should be industry 2. We're not counting, don't forget to count star from 4500. It says count number of rows with each industry 2 value. Want to count the rows that contains industry 2 value. Okay. Find the most common value of industry 2. Come on, let's go for int first. Order by count. Ooh, I would have thought, we'll have thought about that. Order by the count. Let's copy that. Order by the count of those industry 2 value. Let's give it a shot. Let me see if it will be different from this. Oh, I sure it will be different. Why is it different? Hold up, hold up, hold up. I guess I order by the count there. Come on. I lose some points there. That's not fair. So traffic, terrific. For instance, essential when the value you need could be in more than one column. In the next exercise, you use correlations as part of a self join. Okay, so hold up, industry. Mhm. I'm trying to understand the results better. Utilities and gas. Let's see. You can see that pretty well though. Okay, let's see another correlation. Correlations with self join. So you previously joined the company and 4500 tables to find out which companies are in both tables. Now, also include companies from company that are subsidiaries of 4500 companies as well. So to include subsidiaries, you will need to join company to itself to associate a subsidiary with its parent company's information. To do this self-join, use two different aliases from company. Correlatives will help you combine the two ticker columns in the results of self-join to join to 4500. It says join company to itself to add information about a company parent to the original company's information. As a join company to itself, let's think how do we solve this? Join company to itself to add information about a company's parent to the original company's information. Select company original, hold up, company underscore original dots. That's funny because you from oh okay, it has been aliased as company original. definitely from company. So we are selecting the original company name, 4500 title and rank. So I'll select the company name from here, the company name from here, mhm, the 4500 title and rank, 4500 title and rank. So as this, hold on, then join 4500, okay, Control C 4500, and do dot title, just to make sure we're selecting it from title table and make it easy to read. And 4500 rank. Let's see that. For this one, I want to do the rank. I could just simply type rank there, because we have none of that here. Let's just do like that first. And the rank. Aha. That is one of the problems was from, this is definitely from company original. From company. So join to another copy of company with parent company information. Left join company as company parent on company underscore original docs. So what are we going to do? I'm going to use the seeker column. So, so use queries to get parent company seeker if available, and the original company seeker otherwise. So I'm going to use the seeker column here. So okay, we are getting there. So let's join company as company parent or company original here. So seeker equals so we're going to see, so let's join. We're going to return everything from the what? From the company parent here, from the left table. Is this our company original table? So use queries to get the parent company seeker. The inner join to 4500 using seeker. Okay, so there's a seeker column also here. So the inner join. So let's inner join 4500. Use parent seeker if there is one. Otherwise, original seeker. Hold up. What does that mean by that? Use parent seeker. Okay. What is join on? Oh, so I see correlative here. Oh, so I'm going to copy this company original here. So once you want to use it, so equals to this 4500 theta. For clarity, order by rank. Okay, let's see the results. Let's see the result. We have the result. Now this is pretty technical, so I'll try to explain it as possible. It says, let me see if we got the answer correctly first, which I'm pretty sure we did. Oh, we are missing something. To check the second entry in the target list of select statement, the checker is prepared to find title there. Oh, Okay, that is a well because I'm referencing column reference. I'm using table reference and column reference there. That should still work now. Let's run that again. I see having same results. Then check the first entry in the left operand of the binary expression equals the checker specifying company dot parent ID. Hold up. Parent ID. How come parent ID? The left join company as company parent on I think the ticker was that was the column I used to join the two tables now. Hold up. Before I reset the code, hold up first. Let me copy it first. Once you set the code and see what was provided there earlier. Reset the code. Look at this place. Company the underscore original, then company parent. Let me paste the code back. Okay. Let's run it again. Everything because what if I drop this here? It's saying company original dot parent ID. Why the parent ID? Let me copy that here. Because I'm doing the two columns together. I'm doing a table to itself. If I say left join, aha, I have to make sure I'm joining on both of them. If I submit the code, I'll get an error. So I have to make sure I'm using both parent ID here as my joining clause. Now it is not corrected. But let me submit that. I'll come back to why I have to use .id. Why? You check the first entry in the right of under. The balance equals to the checker expected to find company parent.id. Company original. So we are using the parent ID as joining clause, then ID as why that? But before we go, I need to make sure I understand something there. If I close that, so join company to itself, you add information about a company's parent to the original company's information. We are joining this table to itself, but in this our join clause, select company name, select this name this name column here. This is from 4500. Let's ignore that. For company as company original. Join to another copy of company with parents. I think with parents. Company information. Let's join company as company parent. On company original equals to parent ID equals to company parent, which is the second company that we created here, which is the company on the ID. But the challenge I don't understand, why are they using this parent ID and ID as the joining clause? Oh, okay, hold on. Trying to make sense now. That means everywhere it says, let's return everything from this left table here, and only matching records from this company ID here. Oh, okay. I'll read more on that. But my correlative here is taking the company original ticker, use parent ticker if there's one. Otherwise, we are using this ticker column as our joining clause here because of the 4 to 500 table contains a ticker column. Okay. That's quite technical there, really technical. But the challenge there when you're joining, the challenge that I think the only challenge that I could see is that when you're joining a table to itself, on the joining clause, you have to be able to figure out which two columns you use in your joining using the on clause from the on clause. Let us say use the ID and the parent ID. That's funny though. All depending on what on that. So let's continue and finish this chapter one. I need to read more on self-join. Definitely, I need to read more, study more on self-join.
Now it's time to turn to the contents of individual columns, the data types, and the constraints on what values can exist in each column. Foreign keys and primary keys are two types of constraints that limit the values in a column. But columns can also be constrained in other ways. Unique means that each value except null must be different from the values in all other rows. Not null means what it. Now it's time to turn to the contents of individual columns, the data types, and the constraints on what values can exist in each column. Foreign keys and primary keys are two types of constraints that limit the values in a column. But columns can also be constrained in other ways. Unique means that each value except null must be different from the values in all other rows. Not null means what it says. The column cannot contain null values. Check constraints are a way of implementing additional conditions on the values of a column, such as requiring the column only contain positive values or ensuring that the value of one column is greater than the value of another column. Constraints can limit the values in a column, but the main thing that determines what values are allowed is the column's type. Each column in the database can only store one type of data. In this course, we're talking about three of the most common types of data: numeric, character, and date time. These three, along with Boolean, which holds true or false values, are the most common types you'll encounter. But they're not the only ones. There are also special data types to hold monetary values, geometric data like points or lines, and structured data types like XML and JSON. These special types differ more across database implementations than the four common ones. Within the broad categories of numeric, character, or date-time data, there are multiple column types with different details. For example, different numeric types require different amounts of memory per row and can store different ranges of values. In the upcoming chapters, we'll talk more about these specific types, so no need to worry about the details at this point. You can find the type of each column in the entity relationship diagram. Here's the Fortune 500 table. There are three different numeric data types used in the table: integer, real, and numeric. Even if you don't have an entity relationship diagram, the column type is a core piece of information you can expect to find in other kinds of documentation. Values can be converted temporarily from one type to another through a process called casting. When you cast a column as a different type, the data is converted to the new type only for the current query. To change a value's type, use the cast function. First, specify the value you want to cast. This can be a single value or the name of a column. Then use the keyword as. Finally, specify the name of the type you want to convert the data to. Here's an example of casting the single numeric value 3.7 as an integer. Casting from numeric to integer rounds the value to the nearest integer, which is 4. To convert the type of an entire column, enter the name of the column as the value. Here, a column called total is converted to type integer. We need a from clause to specify which table the column comes from. There's an alternate notation for casting values, a double colon. It does the same thing as the cast function, but it's more compact. Put the value to convert before the double colon and the type to cast it as after the double colon. The examples here are the same as those on the previous slide, except with a double colon notation instead of the cast function. After the double colon, a double colon to specify which table the column comes from. There's an alternate notation for casting values, a double colon. It does the same thing as the cast function, but it's more compact. Put the value to convert before the double colon and the type to cast it as after the double colon. The examples here are the same as those on the previous slide, except with a double colon notation.
Cast 3.7 as integer. Select value, double column, then data type integer. Using column, select total, double column, integer. They are casting, okay, which is not of this
Instead of the cast function. Okay, you know what time it is. Let's practice.
Let's practice. So, effects of casting. So when you cast data from one type to another, information can be lost or changed. See how the casting changes values and practice casting data using cast function and the casting with double quotation syntax. So select cast value as data type, select value double notation new type. The instruction says select the profits change and profits change cast as integer from 4500. So the profit change, which is this column here. So the profit change, I just say select profit change 2 times. Okay, we'll see the difference between the first one and the second one. Select profit change, then cast it also. Can use the as clause there as the data type that we want. Look at how values were converted to integer. I want to convert it to integer. And let's take that out. You can see profit change was minus 7.2 before. When converted to integer, nearest whole number is minus 7, 14.4, nearest whole number is 14, 51.5, nearest number is 52. That's quite straightforward then. So compare the result. The next instruction says compare the result of casting or dividing the integer value 10 by 3. The result of dividing the numeric value 10 by 3. Okay, integer value 10, then numeric value 10. You want to divide one. Select compare the result of casting of dividing the integer value 10 with the numeric value 10. Okay, so one is profit change. Profit change divided by 10. Then cast 10. Profit change to integer divided by 10. Let's see the difference. Oops. Oh, I didn't mention the table. Oh. I'm supposed to be referencing the table there. So I'm supposed to use 10. I didn't read the instructions there. by 3. So as we cast 10, divide 10 by 3, then cast 10. It's almost the same thing. We are getting the same results. Oh, it's a numeric. Let's also use integer. Use the keyword numeric there. And let's see the difference. So numeric is a decimal. So 10 divided by 3 is going to return. Normally, when we divide 10 by 3 in SQL, we're going to get a number without the remainder, which is it's going to give us how many 3 can we see in 10. That is 3 3s minus remainder 1. It's not going to return the remainder. When you cast this 10 as numeric, you start getting the remainder. Oh, cool. So the last instruction says, now cast numbers that appear as text as numeric. Note, I think the sensitive notification. Okay, this 1E3 is scientific notation. Okay, cast number that appear as text as numeric. Text as numeric. Okay, this is text. Pass it to numeric. You just add numeric there. Numeric. Let's see. So this is a scientific notation. Let's run that. Let's see. 3.2 minus 1 to 3. This is scientific notation. This is 1000. Okay, this is 1000 minus 3. Break 3 decimal places. So 1 to 3 decimal places. Then 2 for 2 3 1 4. Remove the first this is 0. Then this will remove the 3 leading 0 as well. Okay. And we are good to go. Summarize the distribution of numeric value. I think the last, this is about 2 week chapter 1. It says, was 2017 a good or bad year for revenue of 4,500 companies? Examine how revenue changed from 2016 to 2017 by first looking at the distribution of revenues change and then counting the companies where revenue increased. So look at the distribution of revenue change. Use group by and count to examine the values of revenue change. Let's see the column revenue change from here. Okay, there's a column called revenue change. This one here. So it says select the count of each value of revenue change. What are we counting by? Okay, use group by and count to examine the values of revenue change. What are the results by revenue change to see the distribution? What are we counting by? We need to have what are we selecting? Is it by year? Do you have a year column here? Do you have a year column? There's no year column here. It says examine how revenue change from 2016 to 2017 by first looking at the distribution of revenue changes and then counting the companies whose revenue changed. Distribution of revenue changes, then counting the companies whose revenue changed. We are grouping by words here. Group by words. And even value by revenue change. Let's see, let's start taking it one by one. So we can start making sense. From 4,500. Okay. When the count of each value of revenue change. Okay, revenue change. Sorry about that. Then we're going to count the revenue change. Then group by revenue change. Let's give that a shot. So this is the revenue change. So this is the count. Okay. Let's submit that. Oops, that's correct. So repeat step one, but this time cast revenue change as an integer to reduce number of difference value. Look at the value. So we want to cast revenue change as an integer to reduce the number of different. You can see this is 5.75, so 5.3. So if you have 5.75 there, look at it 38.7, 38.3, 37 now. So it's going to reduce the number of what different value that we have. So when we cast it, okay, so the count of revenue change integer value. Okay, let's cast it first. Revenue change, cast it as integer, integer. Then we're going to select the count of that. Same thing we did earlier. Count from 4,500. But this time around, if you go by this, then order by values of revenue change. And boom, let's compare the result to this one. That's on the code. Aha. So those 57 points, they are much more closer now. Aha. That's correct. So now the last steps. So how many of 4,500 companies had revenues increase in 2017 compared to 2016? To find out, count the rows of 4,500 where revenues change indicates an increase. So count the rows of 4,500. So I just say count star. Count star from 4,500. Where it says where revenue change indicates an increase. Mm, let's see. Let's see. Where the revenue change indicates an increase. It should be greater than what? Greater than what? Oh, the most important thing. Greater than that, definitely greater than zero because there are some negative values there. Okay. Unit change increase greater than zero because some of the values there they are negative decimal. Okay, let's on that. Let's see. We have 298. Look at the time. 298. Let's submit that and see. And boom. You are correct. That's quite interesting. So we're going to see where the revenue change are greater than because the revenue change column here contains negative records and decimal records. We're going to, but that's cool. That's cool. That's quite interesting. But I need to read more about self-join. I'll give it in later. Not interested in waiting later. So we finished chapter one. So we're going to numeric data types and summary functions. Definitely, we're starting chapter two of this exploratory data analysis in SQL on tomorrow live stream. So I'll just close this, go back to the learning dashboard, and achieve something today. So we move forward. 3 more hours to go. Alright, so thanks for staying to the end of this live stream. So if you found value in this video, do support the channel by giving this video a thumbs up and subscribe to the channel also. And put on the notification bell to be the first to know whenever I go live. And share your thoughts with me about this live streaming and sharing my knowledge also, the learning journey. So far, so good. Down in the comment section. I can't wait to read your comments. Don't forget to subscribe, hit the notification bell, and check out the freelance client magnet course under the YouTube description below here, and I'll see you on day 55. Have a wonderful day.